Risk management. Accidents, whether your fault or not, can cause all sorts of tragedies, such as pain, disability, or sadly, even loss of life. Accidents, therefore, can, in some cases, have a significant economic impact not only for the employees, but also for the employers. Accidents can cause bad publicity, as well as impact on quality image. One could arguably say that safety is a vital quality indicator, and therefore good levels of safety will equal good levels of quality. We all want to go home healthy and, most importantly, in one piece at the end of each working day. So, remember, a safe working place is a good working place. This module will focus on risk management. Risk management is the process of identifying, assessing, managing, and controlling threats to an organization's personnel, capital, or earnings. These risks stem from a variety of sources, and we will present some of these existing risks during the next few minutes. According to the European Union Directive, it is the employer's responsibility to recognise and identify hazards and strains at work. Preferably, hazards must be eliminated. If this is not possible, then adequate control measures must be introduced to prevent accidents or other harmful effects. This national legislation principles are followed by all European countries, such as the Occupational Safety and Hazards Act here in Finland. Legislation. Briefly, general law requires two important factors. Risks must be evaluated and risks must be managed. It is important that you eliminate the hazards where possible. When the risk factor cannot be completely removed, it must be somehow managed so that we can get the job done safely. After risk evaluation, sufficient safety precautions must be made. Now, this is a bit tricky. What does it mean? What is sufficient? Sufficient safety precautions indicate that we must do enough in order to control the hazard factor. But how can we ensure this in real life? Sometimes these hazards controls can be very simple to manage. For example, like removing some potential trip hazards away from passageways. Other times, risk removals can be totally the opposite, and consequently, preparations can take a lot of time and effort to get right. An example of this might be erecting scaffolding in order to work safely at heights. It is always easy to be wise after an incident. Make sure you plan ahead and not let Mr. Hindsight get the better of you. Safety standards. So, to help us with this, we have accepted procedures and standards. Safety standards will define minimum safety requirements concerning the task at hand. Now, there are plenty of officially accepted safety standards for all kinds of different tasks, such as safety standards for electrical work, lifting work, or hot work. These safety standards will not only help the employers, but also help the employees work in a way which will meet the legal requirements. As an example, it is quite clear that hot work guarding must be done during hot work, but also after the task is finished. In case of a situation where a legislation is not defined, what does this mean in practice? How could we, in this example, know the length of time needed after the completion of the hot work? To answer this question, we need to look no further than the hot work standards stipulated by Finland and Sweden, who define the minimum time is 60 minutes. You can of course deviate from the standard, and of course nothing forbids us from performing the task for more than 60 minutes. However, it is very important that you do not go below the minimum limit. Safety standards can also define what types of PPE must be used, or additionally, what types of competencies is required for personnel carrying out certain tasks. Following the safety standards in question is easy by ensuring that we always meet the legal requirements. Site instructions. These instructions are based on laws, regulations, and safety standards. Site instructions will define how we apply these general instructions at the site in question. It can define different practical procedures, such as list persons who are authorised to grant certain work permits, define who to contact in case something unexpected happens. It will define special requirements set for tools and equipment, as well as define site instructions in case the site has certain additional safety requirements. Principal employers, as well as principal contractors, might require additional safety measures compared to general safety instructors applied within the industry. Work permits. Then there are work permits. Work permits will explain what is going to happen, where it's going to happen, when it's going to happen, and how it's going to happen. Work permit is a risk evaluation tool, inspection tool, a planning tool, and agreement how the work will be conducted. It will also clarify different agreed tasks and responsibilities between parties. In case something unfortunate should happen, work permits also will serve as an important piece of evidence that will help to demonstrate how the task at hand was supposed to be done and by whom. Clients can always require additional safety measures. Sometimes there are special circumstances that require additional safety measures. Site-specific safety rules might be somewhat more demanding as the regulations in general level, but then we just have to adapt to these increased requirements. Risk management. The first step is the planning process, where we begin by gathering information concerning the task at hand, the people we're working with in the area, as well as site-specific conditions. We will then check what type of hazards can be identified in relation to the task or the work phase we're about to carry out. Risks can be divided into different types of categories. For example, mechanical risks related to movement, such as falling objects or moving machine parts. There's physical risks, like sources of radiation, noise, or vibration. There's also chemical risks, gases, solvents, different substances. We also have biological risks, such as viruses, bacteria, or mold. There are lots of other risk factors and also categories, but we'll discuss those further later on during this course. By the way, often human behaviours are the weakest link. We might be aware of the risk and the proper procedures, but could fail to follow it. Technical solutions fail simply because we didn't use it correctly. Too often, accidents occur because of the human factor, where the person in question didn't carry out the tasks accordingly due to the compliance. Maybe the person was in a hurry. Maybe they were tired. Maybe they failed to notice some relevant aspects. Maybe the person was negligent. Or maybe they were just frustrated and simply wanted to get the task over with. Levels of risk. Risk evaluation attempts to define what the estimated risk actually means to the people concerned with or affected by risk. A large part of this evaluation will be the consideration of how people actually perceive risk. It can also take into the account the economical effects of risk. Risk can be divided into different levels based on their seriousness. The simplest way is to evaluate how likely is an event to happen under the current circumstances and how serious are the consequences. The most serious risk level can be determined in a situation where the likelihood of an incident is highly likely and this event would have severe or even fatal consequences. For an example, this could be climbing on a high slippery roof. On the other end of the scale is an event which is unlikely to happen, and even in the case it should happen, it shouldn't cause any serious end results. Now, this type of risk could be seen as insignificant and to some as being pointless to manage this risk, but it is vital. With this type of risk matrix, we could then evaluate the risk level on a human level as well as on an economical level. There are loads of risk levels between the categories of intolerable risk and insignificant risk. So the fundamental question is therefore, how safe is safe enough? And what is acceptable or a tolerable risk level? Risk evaluation. Risks can be evaluated with different types of methods. Risk management structures are tailored to do more than just point out existing risks. A good risk management structure should also calculate the uncertainties and predict their influence on a business. Consequently, the result is a choice between accepting the risk or simply rejecting them. Acceptance or rejection of the risk is dependent on the tolerance levels that a business already has defined for itself. If a business sets up risk management as a discipline and continues to process for the purpose of identifying and resolving risks, then the risk management structure can be used to support other risk mitigation systems. They include planning, organisation, cost control, and also budgeting. In such a case, the business will not usually experience many surprises because the focus is on proactive risk management. A risk analysis process is a qualitative problem-solving approach that uses various tools of assessments. However, there are of course different types of risk management processes. One example is this, the 4-phase risk control procedure. 1. Identifying the existing risks. Risk identification involves brainstorming. On a general level, we can discuss about the risks that are most common with our line of work or in our line of industry, such as electrical hazards with electrical installations or hot work related risks when you're welding. They're all essential parts of our production. Or you could have risks related to falling down from height when you're doing overhead work. Then of course there are also risks related to the current tasks at hand and current conditions. There are plenty of tools available for risk evaluation, such as structured forms and checklists containing typical risks, structured inspection methods using risk mapping, general knowledge and checklists. There's also safety meetings. Assess the risks, identify the problem, and then try to find an appropriate solution. In an ideal situation, we try to get rid of the risk completely and completely eliminate it by finding an alternative and a risk-free way of how to carry out the task. In case this is not possible, we have to control the risk. 3. Risk control. We could control the risk by a number of factors. We could select the less risky option when available. We could make sure only qualified personnel, instructed and competent people carry out certain tasks. By following simple procedures, by using the right tools intended for the right task, by using the correct PPE, by being prepared in case something unexpected happens or a safety measure fails. 4. Review control. Monitor the results. How are we doing with this? What kind of development have we got? Ensure that our procedures are effective and completely up to date. Monitor possible changes with the external and internal context. This is because changes with the current working conditions as well as risk conditions can change extremely rapidly. That's it for now. We'll learn more about these topics later on as we discuss the importance of qualified personnel, tools, PPE, procedures, instructing and planning further. And don't forget, your attitude also plays an important role here. Some procedures can be shaped until perfection, but key elements in it are the people following the procedure.